The traditional corporate structure routes information through a fixed hierarchy. It is a rigid system that relies on manual intervention at every level. But subject that structure to the right technological pressure, and it reorganizes into a liquid network. Welcome to Tao's Way Salon, Flow Tao Salon. The mechanics of this shift are documented in a March 2026 research report analyzing a framework called OpenClaw and its role in restructuring the enterprise. Throughout 2024 and 2025, companies deployed large language models as stateless co-pilots. A human user typed a prompt, the model generated text, and the system returned to an inert state, waiting for the next command. OpenClaw represents a different approach, the AI operating system. Instead of waiting for prompts, it takes over the enterprise routing hub, orchestrating tasks and executing workflows without human initiation. Installing an autonomous routing layer shifts the logic of task allocation from human managers to the software. It replaces the traditional hierarchy with a series of automated loops. To understand the implications of this shift, we will deconstruct the OpenClaw architecture, examine the compute costs required to maintain it, and define the resulting structural model, the fluid organization. Mastering this architecture is what allows a firm to decouple its total output from its total headcount, the capability that distinguishes high-growth digital organizations from those still bound by manual oversight. True automation faces a technical barrier. Standard LLM application programming interfaces have no memory of past interactions and lack the internal clock required to initiate an action on their own. The OpenClaw framework solves this by inserting a unified gateway layer. This serves as the central routing hub, directing data between the raw models, like GPT-4o or Claude 3.5, and the local execution environment. To solve the amnesia problem, the gateway utilizes a dual memory mechanism, maintaining continuous context across disparate tasks. This splits memory into two distinct files, sessions for short-term, immediate task context, and transcripts for a long-term historical log of the agent's actions. With memory established, the system introduces the component that creates actual autonomy, the heartbeat protocol. The heartbeat runs on a chronological loop, constantly pinging the agent environment and triggering the decision loop. The AI no longer needs a human to hit send. The system prompts itself. When the agent decides to act, it routes commands to the skills matrix, which connects the AI to web browsers, code interpreters, and external APIs. Because autonomous code execution is inherently dangerous, these skills operate inside a Docker sandbox. This creates isolated, transient environments where the agent can run code securely without exposing the host operating system. These layers, the gateway, dual memory, heartbeat, and skills matrix, form a closed decision execution loop. The system perceives the environment, decides on an action, executes it, and logs the result continuously. Human-in-the-loop workflows suffer from latency, as the process halts every time a person must review and approve the next step. The closed loop eliminates this friction. The language model is no longer generating text for a user to read. It is generating specific control commands to manipulate a digital environment. Maintaining this constant background processing requires server infrastructure optimized for continuous polling rather than intermittent bursts of text generation. True AI autonomy is not achieved by training a smarter underlying model. It is achieved by wrapping an existing model in a stateful, constantly beating architectural system. This continuous autonomy alters the cost structure of the enterprise. The heartbeat architecture introduces a new continuous expense, high-volume background compute. This chart plots actual work output against total tokens consumed. It tracks a critical new metric for autonomous systems, the token efficiency rate. The data reveals a severe disparity. Between 85 and 96% of consumed tokens produce no actual external work. These tokens are absorbed entirely by system maintenance. The agent burns thousands of tokens on every loop, just loading its context endo, flushing its memory, and routing internal logic. Traditional web queries are static and efficient. High-frequency background polling forces the model to constantly reread its own state, multiplying token usage. For CTOs budgeting for standard API calls, this efficiency paradox breaks traditional cost forecasting models. But this inefficiency is a requirement. The token burn is the exact price the system pays to maintain situational awareness without human guidance. This changes the primary financial variable in a business's growth model, moving it away from labor logic and toward server logic. Historically, corporate bottlenecks were defined by human payroll limits and the friction of middle management. The new bottleneck is raw compute allocation and API access costs. Running an OpenClaw enterprise means accepting a continuous token tax. The return on that investment is the removal of operational management layers. When the operating system assumes the role of middle management, the physical reality of the workforce must adapt. Rigid IT departments and hierarchical routing logic become obsolete. A system that can dynamically schedule and execute tasks bypasses traditional departmental silos. The macro result is the fluid organization. Without fixed departments, the enterprise operates as a boundaryless network. The AI OS allocates tasks dynamically across nodes based on demand. Zooming into the micro level, traditional digital workers hit a productivity ceiling. They are limited by the physical time it takes to manually execute tasks on a keyboard. To function in a fluid architecture, the individual worker must transition from a manual operator into an ecosystem node. The mechanism that enables this transition is workflow as an asset. Workflow as an asset means extracting a worker's domain expertise, logical decision trees, and standard operating procedures, and packaging them into an executable digital asset. Individuals take these packaged assets and plug them directly into the OpenClaw OS. The system can then autonomously trigger that specific expertise whenever the workflow requires it. This creates a direct symbiosis. The fluid enterprise relies on decentralized ecosystem nodes for specialized execution, while individuals scale their impact beyond physical hours. In 2024, humans sat at desks interacting with SaaS dashboards. In 2026, humans build localized execution logic and let the AI OS handle the dashboard interactions. In an AI-native network, an individual's value is no longer measured by their time in seat. It is measured by the quality, reliability, and scalability of the digital assets they contribute to the system. The implementation of a stateful architecture solves the amnesia problem, which triggers a spike in continuous compute costs, which in turn forces the redesign of the human organization. Analyzing this shift yields 3 observations. Workflow as an asset is the new currency. Workflows belong to decentralized ecosystem nodes, and true autonomy demands a token tax. Operating as an AI-native organization is the only way to match the speed and cost efficiency of a network running on an automated heartbeat. 桃醉沙龙，马年兴隆. Flow Tao Salon, prosperous year of the horse.